Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called One Night's Epic by Megan33, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 in each cell such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell, and no guessing is required. So this is typical fog of war. So say we placed a correct digit in this space. It would clear the fog in that cell and in the 8 surrounding cells around that cell. So that's how fog of war works. We also have cells separated by a knight's move in chess cannot contain the same digit. So in addition to not having any repeats in any row, column, or designated 9-cell region, there are also cells which you cannot have repeats in. So from this cell, you can't have repeats in these cells, or these cells, which are a knight's move away, a chess knight's move away specifically. So there cannot be repeats in any of these cells of this cell here, or the digit in that cell there. We also have digits in a cage do not repeat and sum to the clue in the top left. So these two digits must add up to 5. We don't know if this is 2 or 3 digits here, and they could add up to, but at least these 2 digits plus maybe another digit here or here adds up to 7. These 2 digits have to add up to 5. These 2 digits must add up to 5, and these 2 digits must add up to 5. Same with these, same with these. So for example, if this were, say, a 4, this would have to be a 1, because there's not 3 unique digits that can ever add up to 5, right? Because again, digits in a cage do not repeat. So 3 unique digits can never add up to 5. It's minimum 1 plus 2 plus 3, which is 6. So that's why we know this has to be 2 digits in length. And therefore, if this was 4, this would have to be a 1 here, because they both add up to 5. The cage adds up to 5. And finally, we have digits along each thermometer must increase starting from the bulb end. So this cell must be greater than this. But for any other thermometers, you would have to be increasing from the bulb to the tip. So this could work as 3 and 9. That's fine. Or any combination, just as long as this cell is greater than that cell. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we have a certain amount of digits which are from 1 through 5. So let's color them. And let's color them distinctly. This, we'll say, is red, and that with green adds up to 5. These will be yellow, and we'll just make that pink. So these are a different set that add up to 5. That means this cannot be yellow and pink. This must be a green-red pair here. This cannot be... So this could be, again... So these are all unique different digits, right? Also... This is a knight's move away, so this cannot be red, which makes that green. Therefore, this can't be green, this is red. So we know red is here, red is here. Green is here, green is here. Neither of these can be green because of normal Sudoku and knight's move. So this cannot be green and red, it must be yellow and pink. And this can't be pink because of the pink in the row, so this is yellow. which makes this pink. That means this can't be a yellow-pink pair adding up to 5, so this must be red and green. Green can't be here because it's a knight's move away from that green, so this is red, which makes that green. Interestingly enough, so the 7, this pink cannot be either of these cells, so this cannot be a pink-yellow pair. It must be green and red, so this must be red, which makes this green. So if this were 3 and 4, that would eliminate all possibilities for this cage, right? Because 1 and 4 and 2, 3 are the only possibilities for 2 digits to add up to 5. So this must be 1, 6, or 2, 5. Either way, you have to have a 1 or 2 be part of this cage. And it cannot be here because it must include the yellow or pink, right? We have yellow, pink, green, and red are all distinct digits which add up to 5. And so they must be the digits 1 through 4. So they're all distinctly different digits. These cells all see pink because of normal Sudoku and knight's move. They both see green and red. Therefore, out of the digits, they have to have a yellow. So this is yellow with a 5 or 6 here. So therefore, yellow must be 1 or 2. That means pink is 3 or 4, and this is yellow. So that's yellow is 1 or 2. Green and red cannot be... Where are green and red in row 7? Cannot be in this box because of the green-red pair. Can't be in this box because of the green-red pair. Can't be here because of the green-red pair. Therefore, this must be green or red. So this is the other 5 or 6 here. We'll match yellow with blue, and we'll match this one with orange. So yellow and blue add up to 7. Orange with some other color adds up to, with green or red adds up to, so this is 1 or 2 here, to add up to 7. Sorry, to add up to, actually this doesn't have to be orange. Never mind. That is not guaranteed to be a 5 or 6. It could be 3 and 4 and 3 and 4. So this is 3, 4, 5, 6. It cannot be the other green or red. So this is 1 through 4. Right, this is 3 through 6. Never mind. Okay. Where can yellow be then in this right central box? Cannot be here because of the yellow in the row. Can't be here because of yellow in the column. Can't be the green or the red. Can't be here because of knight's move from this yellow. So this must be a yellow here. So this is 1 or 2, and it is the yellow. Well, okay. This can't be yellow, pink, or green or red. So this cannot be 1, 2, 3, or 4. This has to be a 5 or 6 here. The 5 or 6 is guaranteed to be with yellow or one of green or red. So this must be then green or red, which is 1 or 2. But if this were 5 or 6 and that would be with 1 or 2, you'd have green and red being a 1-2 pair, which is impossible. So this has to be the 3 or 4. This is the green or red 3 or 4. This must then be pink. This green eliminates green here because of knight's move. This red eliminates red here because of knight's move. So this is green, this is red. That means this can't be red, this is green. So all the greens are 1 and 2 also. So again, so then we'll make this again blue with yellow, and we'll make orange with green to add up to 7. This is 1 or 2. That means this cannot be 1 or 2 here. It's 3, 4, 5, or 6 here. It cannot be yellow with blue, obviously, because this yellow sees that yellow, and it's also not a knight's move. Where is the yellow then in this upper central box? Can't be here because of the yellow in the row. Can't be here, can't be here, can't be here, so this must be yellow here. Okay. Where is red in the central box? Cannot be here because of the red in the row. Can't be here because red in the row. Can't be here because red in the row. So this must be red there. Okay. Where is red? Okay, that's not helpful. Where is yellow? In this upper left-hand box. Can't be here because of the yellow in the row. Can't be here because of yellow in the row. Can't be here because of a knight's move from that yellow. So yellow has to be one of these two. Where is yellow in row 5? Cannot be here because of yellow in the box. Can't be here because of yellow in the box. This is red, so one of these is yellow. Where is yellow in column 7? Can't be here because of yellow in the box. Can't be here because of yellow in the box. Can't be here because yellow in the row. Can't be here because of knight's move yellow. So this must be yellow here. That means one of these three is a yellow here. Okay. Reds. Reds is one of these two in column 8. One of these two in column 5, and in column 2, it's one of these two. Well, where can red be in row 3 then? It has to be here, so this cannot be red here. Okay. What about greens? Greens in upper right-hand box, it has to be one of those two. Okay, so in this central box cannot be here, and this is already red. So that forces this to be green. Where is green in this box, or column 4? Cannot be here because of the green in the box. Can't be here because of the green in the box. Can't be here because of the green in the row, so it's one of these two. But we know this is a yellow. So this cannot be green. Therefore, this is green here. This must be the orange with it, and is 5 or 6. Okay, that means this can't be green here, so this must be green over there. Green and red do not add up to 7. This must be orange. That means this is red here. That eliminates red from being there. So this must be red there. So we've got all the reds down. We have all the oranges down. Actually, we don't have any of the oranges. Where can orange be in row 3? Cannot be here because of the orange in the box. Can't be here because of the orange in the box. Can't be here because of knight's move, so it must be here. So then orange in column 3 must be one of those 3. Okay. Where is the orange in this right central box? Cannot be here or here because of the oranges in the rows and columns. These are already filled out, so this must be orange there. That means where's orange in the central box? It must be one of these two cells. Where is orange in column 7? It has to be one of these two cells because it can't be here because that's yellow. Okay. Orange cannot, no, that's not true. One of these could be orange. One of these is orange. This is yellow, and this is red. So orange has to be one of these 3 or this one. Okay, that's pretty broad still. Okay. Where is pink in this upper central box? Cannot be here. Cannot be either of these cells because of knight's move, and these are all filled out, so it must be one of these two. Which means pink has to be one of these three cells here in column 4. I think we have all the green set, right? We do. We should have all the red set also, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do we have all the green set? 1, 2, 3, 4. Oh, we already said that. Green and red. The yellows are a little uncertain. Oranges are uncertain. Pinks are definitely uncertain. Where can pink be in this upper right-hand box? It has to be here, here, or here. Oh, this digit. Okay, we have certain information here. This digit is less than another digit, and it's 5 or 6. But we already have 1, 2, 3, 4 accounted for in this box. So this digit then, orange, has to be 6. So we don't know where orange is here, so let's remove the oranges here. Let's remove everything that we're not certain of. So again, orange cannot be here, cannot be here. These are filled out, so this must be orange. Let's remove all the yellows that we're not certain of either. And the pinks we're not certain of. Okay. Okay, so orange has to be smaller than another digit. And it cannot be 1, 2, 3, 4. Sorry, it has to be larger than another digit. So the oranges all have to be 6. The blues, which makes this a blue, has to be a 5. Obviously, the yellows then are 2s. The pinks are 3. The greens are 1. And the reds are 4. Okay, so that fills that. This cannot be 1, 2, 3, or 4. So this is actually also cannot be 1 through 6. Remaining digits in column 5 are 7 through 9. And this has to be smaller than that. So this is 7 or 8, which makes this 8 or 9 here. This digit could be 5. It cannot be 3 because of knight's move. It can't be 1, 2, or 4 because of the 1, 2, 4 in the rows and columns. So this could be 5, could be 7, could be 8. It has to then be 7, 8, or 9. So all the 1s are done. You can remove those. All the 2s are not necessarily done. So 2 can be either here or here. 2 has to be one of these two, and 2 has to be one of these 3. 3s are this can't be 3, so 3 has to be one of those 2. This can't be 3 because of the 3 there. This can't be 3. Where is the 3 in column 4 then? Can't be here because one of these two must be 3. This is a knight's move away. This is also a knight's move away. This is a knight's move away, so it has to be here. And because this one's greater than that cell. So this is a 3 here. So we can remove the pink. 4s are all done. 5s. Interesting. Where is the 5 in the central box? It cannot be here because of knight's move. Can't be here because of this 5, so it must be one of these two. Well, where is the 5 then in row 5? Can't be here because one of these is 5, and these are removed because of the knight's move there. This 5 eliminates 5 in this cell, so this must be 5 here, which forces this to be a 2-5 pair. Because those are the only places for 2 and 5. Therefore, that leaves us as 7, 8, 9, 7, 8, 9, 7, 8, 9, which means we have a 7, 8, 9 triplet in the central box, so this can't be 7, 8, or 9. Therefore, this must be a 5, 6 pair. We can remove the orange. Where is the 6? The 6 cannot be here because it must be greater than 7 or 8. It must be either here or here. And these both see this cell. This by normal Sudoku and this by Knight's move. So this can never be a 6. This is 5. That makes this 6. This 5 eliminates 5 here. So this must be 7, 8, 2, 8, 9 as a large space. This 6 eliminates 6 here, so this must be a 6 here. This has to be 7, 8, or 9. That leaves the remaining digit in column 4 as a 5. So this is a 5. We have 7, 8, 9 remaining in row 4 and row 6. We need a 3. We have 3, 7, 8, 9 in the rest of row 3. We have 5, 7, 8, 9 in the rest of column 8, but this can't be 5 because of the 5 in the row, so this must be a 5 here, which makes this 7, 8, 9. Remaining digits in column 9 are 3, 7, 8, 9. Okay. Remaining digits in... So where is the 6 in column 3? It must be one of those two. Where is the 6 in column 7? It must be one of those two. That's not that helpful. Where... Remaining digits of column 6 are 3, 7, 8, 9. Remaining digits of column 7, there's a lot. We have all the 1s, we don't have all the 2s. We do have all the 4s. We don't have all the 5s. Remaining digits in row 8 have to be 3, 5, 7, 8, 9. This can't be 3 because of the 3 in the column. This can't be 3 because of Knight's move from that 3. Where is the 3 possible in row 8? It has to be here. So this is 3, which eliminates 3 here. We have a 7, 8, 9 triplet in row 3, which eliminates 7, 8, 9 in the rest of the row. So this can't be 7, 8, or 9. It's 3, which eliminates 3 here and 3 here. We have a 7, 8, 9 triplet in this lower right-hand box. That leaves just a 3, 6 pair in the rest of that box. So this is 3 and 6. This is 3 and 6. This 3 eliminates 3 here, so that's 6, which makes that 3. That leaves this as a 6 in the rest of row 7. This cannot be 6 here. We have 2, 5, 7, 8, 9 remaining in column 3. This cannot be 5, so this is 2, 7, 8, 9. Where are the 5s possible? It could be here or here, but this can't be 5 because of a Knight's move away from that 5. So this becomes 5 here, which means where's a 2 in row 2? It has to be here. So that's 2, which makes this 5, which makes that 2. This can no longer be 5. This can't be 2. Where's the 2 in column 3? It must be here. So this is 2, which eliminates 2 in the rest of the row. Where's the 5 remaining? It has to be here. We have 7, 8, 9 triplet in row 9. We have a 7, 8, 9 triplet in column 2, which leaves this digit as a 3. So this can't be 3 anymore. Whereas the 3 in box or column 6, it has to be here. So this is 3. That means this can't be 3 here. We have 5, 7, 8, and 9 remaining, and this can't be 5. Whereas the 5 in column 7, it must be here. So this is 5, which makes this 7, 8, 9, 7, 8, 9, 7, 8, 9. Now we have to start coloring these different 7, 8, 9s. We'll make this red, yellow, and blue. This has to be blue. That makes this yellow. This cannot be blue here because it's the knight's move away. So blue has to be one of those two. Which means this can't be blue, so blue's one of those two. Which means one of these two has to be blue. This cannot be blue. One of these two is blue, so this can't be blue here. So this is blue there. This is a blue-red combination, which means this can't be blue or red, it's yellow. That forces this to be red. This is blue and yellow, therefore that makes this red, so this is blue and yellow there, which makes this red, not green, red. That makes this yellow. That makes this red, so this is a blue-yellow combination. Okay. This can't be red, so this is also blue and yellow. This can't be yellow, so this is blue or red. This has to be a blue here, because there's no other place for it in row 7. This is a red-yellow combination. This yellow eliminates yellow from that possibility because of knight's move. So this is blue, which means this can't be blue. That's yellow. Therefore, that makes this a blue. Since this is blue, this can't be blue. This is red, which means this can't be red. So that's blue, which means this can't be blue. So that's red. This is blue. This is blue. This is blue, so that eliminates blue from being there. So that's yellow, which means this can't be yellow. That's blue, which means this can't be blue. That's yellow, which forces this to be a blue. There we have yellow, blue here. That forces this to be red, which makes this yellow. That means this can't be yellow here, so this is red, which means this can't be red. This is yellow. So the blue is less than yellow, which is less than red. So blue is 7. Yellow is 8, and red is 9. And that's the solution. Pretty cool, actually. Pretty nice use of knight's move. And, the cages, particularly, that you were very restricted on what you could have, right? That was a nice little coloring exercise. So this is why I like doing coloring a lot. Well, not the only reason. I just enjoy coloring, but it's very helpful in solving some Sudokus because you can figure out where each digit has to be. And it's particularly useful for knight's move because that's very restrictive on what on positionings of where certain digits can be, right? So therefore we knew this cell could not be either of this digit could never be either of these digits. So therefore, this had to be a different pair that adds up to 5 than these pair, right? Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.